So we would like to solve this initial value problem, and we want to use an infinite series in the powers of t as a solution. So what we do is this, that so if we assume that the solution is of this form, then all we will do is just use simple algebra to substitute the values in here and compare the like powers or the coefficients of like powers. So first let's figure out our first derivative, and so what that will be, I'm just it's just differentiating a polynomial. So you got the you have the a0 going away, all right, and here we have the first derivative. Now in the same way we will compute the second derivative, and the second derivative would be that here. So let me just take a stop it for a moment and just finish it and then come back to you. So now we have the second derivative here, and the first derivative is here as a power series. And for the tangent inverse t, let's recall the Maclaurin series of tangent inverse. So the Maclaurin series of tangent inverse t is this, or we can write that in the expanded form. And here we are not using summation notations in our calculations. We'll do that in another problem. We just want to keep things simple at the moment. So when n is 0, what we have here is simply t. When n is 1, we have negative t cubed over 3. Okay, and then we got t to the power 5 over 5 with a positive sign, and excuse me, okay, with a positive sign. And let's write the next term. That's going to be t to the 7 over 7, and then it will proceed in the same manner. Okay, so now I'm sorry, I'm using a trackpad. So here we go. Okay, so now we will substitute all these values in the original equation. So this is what we have for dy dt. Then for t times dy dt, what we got is, so we will just have this series multiplied by t, okay, and that becomes a1t, then a2t square, then a3t cubed. Everything gets multiplied by t, right? Okay, and then you got negative y, right? So negative y will become simply, sorry about that, all these guys then become negative. Okay, so there we are. So now let's just go ahead and combine like terms, okay, and we will just go only up to a5. And if we were writing in general notations as we would do later, then we would just do it that way. Okay, so if we look at the constants on this side, when we combine all these, what we get, 2a2, there is no constant term in here, and then we got negative a0. So we got 2a2 minus a sub 0, right? And likewise we will collect the coefficients of t and proceed that way. So I took leave to finish the other ones. So here let me just quickly finish the coefficients for t cube for you. So they will be, let me reduce this size here. So they will be this negative 5 times 4 times a sub 5, then we get plus 3a sub 3, and then simply minus a sub 3, and then t cubed. Okay, and now we have gotten, we decided to stop at a sub 5 for the 5th term, so we have gotten that much. And then this quantity or this series has to equal right here this expansion for tangent inverse t. So what will that give? There is no constant term on the right hand side. Oops, sorry about that. So this will be 0, and then this is simply 6 a sub 3, right? So we have 6 a sub 3, and then these a1s cancel, and the coefficient of t is 1, so that simply becomes a 1. Then we got 12 a sub 4, and of course we were doing it in our typical manner. Then we will keep the pattern, but here let's just leave it like this. So we got 12 a sub 4 plus a2, that's the coefficient of t square, and that's going to be 0 because there is no t square in here. And then we got 20 a to the 5 minus, so 20 a to the 5 minus 2a3, sorry, and that becomes equal to how much? Negative 1/3. Okay, and we just wrote it just to get an idea of the beginning of this series, or approximating the series to a polynomial. So what does this give us? This gives us that a2 is a sub 0 divided by 2, right? So what we are having is, looks like that we will have a type of a relationship between the coefficient with indices like 2 units apart, and well, a3 here is determined, fortunately, because so here a3 is 1/6, okay, and then we have a sub 4 as so we got a sub 4 as negative 1/12 a sub 2, okay, and then in here we know a sub 3 is 1/6, so what we have is that then here we got 1/6, okay, so that is going to be 1/3, and moving over to the other side it would become negative 2/3. So a sub 5 is going to become what then? 20 a sub 5 is negative 2/3. So that is negative 1/30. Okay, and that's how it goes on. Now notice this here, that now remember we had initial conditions here, that is y sub 0 is -1, so y at 0 is -1 and y prime at 0 is 1. So what does that mean is this, that y at 0, if you look at it, what it is, all the terms here will be 0. So what does this give us? This gives us that a sub 0 is -1, right? And then here it says that y prime 0, y prime at 0 is 1. So what will that give us? That all these guys will be 0. This is y prime. So we will simply have a1 equals 1. So a0 is -1 and a1 is 1. So if we go to our calculation here, then what we get in here is that a0 is -1. Let me enlarge it, because just a second. Okay, so a0 is -1, so that will give us what? This is negative. a2 is -1/2, right? And a3 is this, and right here we have again a2 is -1/2. So this becomes 1/24. Okay, so what our solution would be then? We had a0 as -1, right? Then plus a1 was 1, so that will be simply t. And then a2 is -2, so we -1/2 I meant, so that's -1/t square. Okay, and then for a3 we have 1/6. Then we got t cubed. Then we have 1/24 t to the power 4. Okay, and at the end we have s times t to the 5. So you had a real extensive review of polynomials here. Okay, so that's representation of the series up to the power 5 on t. Okay.